Okay, class to Alpha, good morning. Can you hear me?
Can.
Okay, good, very nice. Right. Mm, I think we can start now, or you want to wait for another maybe 1 or 2 minutes? Okay, before I start the class, how about the exercise that I gave you last Monday on page, I think page 111. 111, only page 111. Any problem? Page 111. Yes, only page 111. Okay, any problem? Our workbook exercises, page 111, only one, only one, I think, one page that I asked you to do on Monday. Let me try to open the... Okay, never mind. I will try to share the answer later. Now it's 10:59. I think we can start the class now. Okay. All right. Okay, class. We continue the class right now. So last time we are discussing about pressure. Okay. And then we have what we call gas pressure and then liquid pressure. All right. And then our last topic for chapter 8 is pressure. So we just continue on gas pressure. If you still remember on Monday, there are two factors that affecting the air pressure, right? Number one is the volume, and then number two is the temperature. Okay, meaning that if the volume of the gas particle or the volume of the gas increase, so automatically or at the same time the pressure also increase a little bit. Okay, for example here I just repeat again, for you to remember this one. For example, the picture over here. All right, when gas being compressed, meaning that if you exert the force, on the piston over here, when you exert the force at the piston over here, okay, you can see the volume inside, the volume of the what we call gas inside will increase. So at the same time, the pressure also increase. Okay, and then at the picture A or diagram A, we can see the air pressure inside, the air pressure inside and outside is equal. Okay, the pressure inside and outside is equal. Then you can see that the what we call the piston is not being pushed downward. The piston is not being pushed downward. All right. That's why we can say here the pressure inside and outside of this container is the same. Okay. The pressure increase when you push down the piston, and then you can see the particles or the atom inside the air here is being compressed and the volume is increased. So we can say that when the volume of the air particle is increased because of it being compressed, so the pressure is also increased before being compressed and after being compressed. So what happened when we release the force? What happened when we stop pushing the piston? When we stop pushing the piston downward, okay, the piston will go back to its original position, and then the air will equalize. The air pressure inside will equalize. Outside and inside pressure will be equalized when we release or we stop push the piston. Okay, can you understand this, class? What happened if, for example, like this? I just draw another picture over here. Okay, so you remember this, right? Picture A and picture B. Picture A, when let me zoom it a bit. Okay, picture A, when we do not push the piston, and then the pressure inside and the pressure outside is equal. Okay, when I ask you which one has higher air pressure, no, meaning that the air pressure is equal inside and outside because we do not push the piston down. Okay, and then for B, when we push the piston down, the volume in the air particles inside the container will increase because it's being compressed, and then we can say that the inside the container has higher pressure than outside the container. Outside the container, we have lower air pressure. Inside the container, we have higher air pressure. Okay, how about like this? I just draw you another picture over here. Okay, I just try to draw you another picture over here. Let me zoom it a bit. Situation C, whether you can understand it or not. Is situation C, okay, this is situation C. I am using the same container. I am using the same container, but this time I will, okay, this time, how many particles inside? For example, this 11, right? 1, 2, 3, 4, 5, 6, 7, 9, 10, 11. Okay, this is just to show you the particle lah, yeah. This is just to show you the particle inside the container. Okay, right now, can you see the difference right now? We are using same size of container, same piston. This is also the piston over here. This is the piston. This is the container. Okay, this is also the container. Container. Okay, now I am not pushing it. I am not pushing it downward. I pull it upwards. P-U-L-L. I pull it upward. Okay, until the maximum. Can you see the difference over here? Can you see the difference?
Yes.
Okay, I just try to zoom out a bit. Okay, A, I did not push and did not pull. Okay, I did not on diagram A, I did not pull the piston. I did not push the piston. So the air inside and air outside is equal. Okay, so in B, I push the piston, and then the air particle inside the container, the volume will increase, and then at the same time, the air pressure also increase. How about air at the outside? The air pressure at outside is lower at B, and then the air pressure inside is higher. Why? Because I compress the air. when I compress the air and then the volume increase. How about in C? This is another one. I pull the piston upward until the volume inside become what? Until the volume inside, what happened to the volume of air inside? Is it increase or decrease?
Decrease.
Yes, until it become decrease. Okay, I pull, by using the force, I pull the piston upward. Okay, so at the same time, when the volume decrease, what happened to the air pressure inside? What happened to
Lower.
the pressure? Okay, the air pressure become lower. Or the air pressure become lower, or the air pressure become decreased. And then how about the air pressure outside? The air pressure outside, is it higher or lower?
Higher.
Okay, the air pressure outside is higher. Okay, the air pressure outside is higher. Okay, can you understand this? Boleh tak? So, if I release the piston in C, in diagram C, if I release the piston, what happened to the piston? What happened to the piston?
Will push a little bit.
Yes, it will push a little bit. It will move a little bit downward until the air inside, until the air pressure inside and then the air pressure outside become equalized. Then later on, it will be like in diagram A. It will be in diagram A. When we do not push or we do not pull the pressure until it stops. Okay, the piston will stop when the air inside, the air pressure inside and the air pressure outside is equal. If the air pressure equal, then it will stop. Okay. In B, when we push, air inside will be increased. The air pressure inside increase. If I release the piston in B, the piston will be back to normal. Same with the C. If I pull the air pressure, if I pull the piston, the air pressure inside the container become decrease and then the air pressure become lower. If I release the piston, okay, I stop pulling the piston, then the piston will go down back to normal because they want to equalize the pressure, the air pressure, equalize the air pressure inside and outside the container. Okay, class? Make sure you understand this. Can you identify the difference? Right? Identify the difference. Because in A is normal. Inside, outside air pressure is the same. A. This one on B, inside the container air pressure is higher because you can see the particle is close together and then it what we call move more freely. Okay, and then in picture C, you can see the distance between the particle is much further away. All right, so it is not got what we call the particle inside C. It's not so moving so vigorously, so it has less collide with the wall of the container. So we can say the volume is decreased and then the air pressure is lower in C. In C. Okay, this is what we call the volume of the air, whether it is increased or decreased. If the volume, you just remember, if the volume increase, the air pressure also increase. Okay, and then if the volume decrease, the air pressure also the air pressure also decrease. Sorry, if the volume decrease, the air pressure also decrease. Yes. Okay, you understand this? Make sure you understand this. All right. Next is the temperature. Temperature, I already explained you last Monday. When you try to heat the air, the particle is getting more vigorous. The movement of the particle of air is much faster. If the particle of the air is much faster, then the air pressure will increase. But not increase too much lah, not increase too much, but maybe only slightly increase when there is a heat. Apabila panas, tekanan akan tambah sedikit sahaja. Okay. Right. Can you understand this? This is the relationship or the factor affecting the air pressure. Two. Number one is volume, and then the second one is temperature. Right? Volume and temperature. Okay. All right. Next one is the atmospheric pressure. Okay. Because we are now living in the earth, right? We are surrounded with what? We are surrounded with air. We are surrounded with air, right? So do you still remember the composition of air? Still remember in Form 1, composition of air consists of oxygen, carbon dioxide, nitrogen, and then inert gas and others, right? Okay, this is what we call by atmospheric pressure. Atmospheric pressure, because we are used to the pressure right now. So the pressure right now is about what we call 1 atm. Because human, we are living in the earth, we are get used to the pressure right now, because on our earth right now, we are breathe in and breathe out easily because of the atmospheric pressure. Right? Okay. What is this? The air pressure? Okay, the pressure outside. What is the atmospheric pressure? The air pressure outside. The air pressure outside meaning the air pressure right now. Outside us. We call it atmospheric pressure. So atmospheric pressure is pressure exerted by the atmosphere on the surface of the earth and all objects on earth. This is atmospheric pressure. At the surface of the earth, this is our air pressure right now. Okay, we call it some of the unit, we call it 1 atm. 1 atm. ATM is not machine. ATM is atmospheric. ATM. ATM is atmospheric pressure. One of the unit to measuring air pressure. Okay. One of the what we call unit to measure air pressure. Okay, we call it ATM. Wait a second. Yeah. Okay. Okay. For example, if you have a watch, there is one unit at the watch which labeled 30 atm. Can you identify here? This is one of the unit of the watch over here. Okay, you can see here, automatic. The watch is automatic lah. And then some of the watch using has this label. This one is 30 atm. Can you see this? ATM mean what? ATM mean atmospheric pressure. So 1 atm is the air pressure, the amount or the power of air pressure on the surface of the earth. On the surface of the earth is 1 atm. So 30 atm. 30 atm meaning that what, class? What do you understand about 30 atm on on the label on the watch, some of the watch. This watch, we call it a diver watch. Diver watch, meaning that it is water resistant, and then it can be wear by diver. They want to dive into the ocean, the deepest in the ocean, they can watch this. They can wear this watch. Okay, 30 ATM, meaning that the watch can resist what? The watch can
30
resist,
meter.
not 30 meter. Not 30 meter. Meter is the depth, right? Meter is the depth. ATM is meaning that the watch here can resist the what we call the pressure. Can resist the pressure 30 times the pressure of atmosphere. 30 times the what we call the 30 times the pressure of atmosphere. It can resist. It can withstand 30 times the pressure of atmosphere. At the surface, you must remember class, at the surface of the earth, right now, at home, at your home, at my home right now, the air pressure around us is 1 atm. 1 atm is okay lah, right? The pressure is normal. But inside the water, the pressure will increase. 30 atm, you think it is a low pressure or high pressure? You think 30 atm? Do you think the pressure is low or high? 30 atm.
High.
High, yes. 30 atm, very high pressure. Right now, 1 atm. We are now at 1 atm. We can breathe easily. Right, we can breathe easily. But inside the water, 30 atm is very high pressure. So this watch can withstand high pressure, about 30 atm. ATM is atmospheric pressure. ATM is atmospheric pressure. Some of the watch use meter, 30 meter, 2 meter, or 5 meter. That is meter. Meter is the depth. The depth of the what we call ocean. But this one using pressure, right? Can we have another label over here? Some of the watch use what we call meter, and then special watch they use what we call ATM. This is another example. How many ATM? How many? This one. 10?
10.
10 atm, right? Meaning that the watch can withstand 10 pressure, 10 atmospheric pressure. Okay? Special watch, special watch. Diver watch, for example, can withstand this type of pressure. Oh, this one very small, right? Okay. This is atmospheric pressure. So the application of concept of air pressure in daily life. Okay. So this is an experiment. I will skip the experiment. I just directly to page 194. This is the application of concept of air pressure in our daily life. Make sure you understand in this topic. Make sure you identify which air pressure is lower and which air pressure is higher. Okay. Number one, the application concept of air pressure in daily life by using a plunger. Plunger. You know the plunger. If you want to unblock the clog, the blockage on the sink, we use plunger. All right. So in this, when you use plunger, either we push or we pull the plunger. Okay, we have two action over here. One is push and one in pull. Okay, for example, you take a look at the page, the first, what we call the first diagram first. A, this one on A, and then this B. This is B. A, when you push the plunger downward. You push the plunger downward. So what happened to the air pressure inside? The air pressure inside become higher or become lower?
Higher.
Higher, right? Huh? I think the diagram here is not very accurate there. Okay. Actually, when you push the plunger inside, the air pressure inside become higher. And then what happen if the plunger, the air pressure inside become higher? If the air become higher, meaning that the volume is higher also. You push, the air is not forced out actually. Air is not forced out. Maybe will force out a little bit lah, because of the plunger is made from the rubber, right? Rubber plunger. A rubber plunger. Okay. When you push, the air inside become compressed. The air inside the plunger become compressed, and then the air volume also increase, and then also the air pressure inside become decrease, become increase. So what happen if you push the plunger? The blockage here will going out or going in? The blockage here will go out or
Going
in?
out.
Yes, will going out because of the higher pressure over here. Okay, higher pressure over here, higher pressure inside the plunger, and then it will go out. It will go out. Okay. And then second picture, if you try to pull the second action, you want to pull the plunger. So what happened to the air particle inside? What happened to the volume? The volume inside will become decrease. And then what happened to the air pressure? Increase or decrease inside B? The air pressure become decrease. Right, the air pressure inside become lower. The outside pressure in X become higher. So what happened? The blockage will go in or go out?
Go in.
Yes, it will go in. This one going out, and then this one going in. If you what we call use the both action, pull and pull, push, pull and push, pull the plunger, what happened to the blockage here? The blockage will go inside, outside, until the blockage is unclogged. Then it will remove or it will move from the blockage. You can understand here, boleh faham tak ini? The action of pushing the plunger and pulling the plunger, because we want to what we call change the air pressure inside. When you push the plunger, the air pressure inside the plunger here become high, and then the blockage will try to get it out. And then at B, when you try to pull up the plunger, okay, the air pressure inside the container, inside the plunger here will go lower, so the blockage will try to go in. Okay, and then if you what we call use both action like push, pull, push and pull, and then maybe after you try it a few times, the blockage over here will release. Okay, make sure you understand this. Okay, that is number one. Okay, this one. This is what we call Magdeburg hemisphere. Okay, Magdeburg hemisphere. So, inside is vacuum. Vacuum mean what, class? Vacuum mean there is air or no air inside? Magdeburg.
No.
Okay, vacuum mean there is no air. What happen if there is no air inside the hemisphere? What happened to the air pressure inside? Is it lower or higher?
Lower.
If there is, okay, if there
Higher.
is no, sorry. If there is no air, vacuum meaning there is no air. So what happened inside? Inside is okay, no air. meaning there is less volume. So what happened to the air pressure? High or low pressure inside? We have low pressure. Inside, this is inside. Outside, the atmospheric pressure outside, because normal 1 atm, because outside has higher pressure lah, higher pressure. So the higher pressure of gas will exert the outside container. So when you try to separate the Magdeburg hemisphere, can or cannot? When you try to separate the two sides of the container, can push or cannot pull? You try to separate it.
Cannot.
It cannot be separated because of the high pressure inside. The lower pressure inside, the higher pressure outside will keep the hemisphere tight. You cannot pull it, you cannot pull it easily. You cannot pull it easily because of the air pressure exerted on the outside of the container will keep the Magdeburg hemisphere closely tied together. Okay, closely tied together. Okay, same things with this lah. Got this or no? Okay, same with this. I will try to show you the picture. Same with this. We call it what is the glass holder, bracket, wall. What is the name? Class, you still remember? We call it what? When you stick the bracket, we call it what? I'm so forgot lah. This one. I will try to draw you the picture. I already forgot the name of that things lah. If you have for example, a glass, if you have a glass wall over here, and then you have the rubber holder, for example. This is, we call it what? Made from rubber. Okay, this may be the glass. Yes? What we call that? It looks like stick to the glass. Forgot the name. Glass holder bracket. I forgot the name lah. Not glass holder. This one. Ayo, we call it what? This. Vacuum glass sucker. Okay. Vacuum glass suction cup. Ayo, very, very hard. This one, we call it suction cup. Kan? Ini, tahu kan ini? This is suction cup. Okay, suction cup also using the same principle as Magdeburg hemisphere. Okay, this one boleh nampak tak ni kelas? Can you see this? This is suction cup. Suction cup. So many. Alright, this is what we call by suction cup. This one, I draw this one just now. This one, this is suction cup. Using the same principle as Magdeburg hemisphere. When you pull the suction cup towards the glass or towards the wall, what happened to the air pressure inside? What happened to the air inside? Will become vacuum, right? Will become vacuum. The air, when you pull the suction cup, the air will get out. The air will get out and then will live inside vacuum, meaning that there is lower pressure. Why low pressure? Because inside vacuum. You have low pressure because you have low volume. If the inside have low volume of air, so it will become low pressure. So how about the air pressure outside? The air pressure outside higher or lower?
Higher.
Yes, the air pressure outside is higher, so it will push against the suction cup. The higher air pressure will push against the suction cup. So if you try to pull out the suction cup, is difficult or easy? If you try to pull, if you try to remove the suction cup from the glass, for example, easier or a bit harder? Class? If you try to remove it, it will become a little bit harder lah, because why? Outside air pressure is higher, lower inside the suction cup, inside the suction cup the air pressure is lower, or sometimes it's become vacuum. Okay, so it will stick to the glass, to the wall. Okay, by using this one. Also using the concept of what? This device also use the same concept as air pressure. Okay, air pressure. Right? Okay, next one. Okay, this one, when you try to suck up the air using the straw, which one has higher air pressure, inside or outside? Okay, inside the straw over here, higher or lower air pressure?
Higher.
Higher or lower? Okay, you must remember, we try to suck up by using our lung. We want to remove or we add the air inside the straw over here. We try to remove the air, right? We want to suck up this one. So the pressure over here become higher or lower? Inside the straw here.
Lower.
Yes, it will become less or lower. Lower air pressure. Lower air pressure inside. So air pressure outside, number 2. Air pressure outside is higher or lower?
Higher.
Higher. Air pressure outside higher. The air pressure inside the straw is lower. So what happened to the water? What happened to the liquid? The liquid will be pushed up the straw. Okay? Can you understand this? Boleh ya? Again, if we blow out the, we add more air inside the straw. We do not suck the straw. If you blow it, if you blow, meaning that you add more air inside the straw, which meaning that the air pressure inside become lower or higher when you
Higher.
blow it. It will go higher, and then what happened to the air, to the water inside the straw will remove. Right? You must understand this. If you suck up the straw, you want to remove the air over here, and then the air will enter the straw, and they will move upward because of the lower air pressure inside the straw, and then higher pressure outside the straw. Okay, that's why we can the water can enter the straw and then enter our mouth. Okay, so this is by using straw. Okay, this one is what we call a siphoning. Siphon. S-Y-P-H-O-N. So you must try to understand which one has higher air pressure. Which one has lower air pressure? Okay. Number one, the end of the tube B placed lower at the end of the tube A. And then the water will flow out from tube B, from the end of the B. Okay. Water in tube flow out and create an area of low pressure in the tube. Atmospheric pressure push the water into the tube so the water flow continuously. Okay. The condition here, in order to remove the air inside the aquarium completely, the end of A over here, okay, must be higher than the end of B. Okay. B, the end of B must be lower than A lah, in order to complete, to remove all the water inside the aquarium tank. Okay. If higher or equal, if like this, if the tube is like this, so it will not, what we call, we cannot use the air pressure to remove the water. Okay. Or if you have higher like this also cannot. The end of the tube, for example, B, it must be lower than the end of tube inside the aquarium tank. And then when there is a water flow, the water will flow continuously until all the tank, all the water in the tank will be removed. Okay? Can you understand this? Right. My question, where is the water will stop flowing? Number 1, number 2, or number 3? The water will stop flowing at what? The water will stop flowing at number 1, number 2, or number 3? Class. The water stop flowing at number 1, number 2, or number 3?
3.
Number 3? Is it number 3?
No.
The water will stop flowing at number 1, because can you see here? Because the end, the end of the tube at A is just upper, this one. So the water on the water tank here is not completely, what we call remove. If I have another, okay, if I have another tube over here, if I have another tube over here, from here, okay, and then outside like this. Okay. If I have the tube like this, okay. So it can, what we call empty the tank, what we call nearly empty the tank lah, because the end of the B over here, and this one is C lah. This is C, and then this is D. C over here is lower. Is lower. At the what we call the base of the tank. Okay, it depend on the position of either tube, or the opening of the tube. All right. So if like this, can you understand this? That's other what we call, you try to understand it lah. Boleh faham tak ini? Okay. 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 All right. This one later lah ya. Application, the next application is later. We will try to explain it later. So now it's 11:42. Only takes time, extra time only. Also, okay, never mind. Okay, you have any question?
No.
Okay, so we stop the class right now. Okay, thank you for your listening. So meet you all again next week lah, yeah. The next class next week. Okay. So exercise, I will give the exercise later on our Telegram group. Okay, you can leave the class now. Right. Thank you.
Thank you, teacher.
Thank you very
Thank
much.
you.
Bye bye.
Thank you, teacher.
Thank you.